Hello all and welcome back to the channel. Today we're going to be talking about the most underrated planet in the solar system, and that is Uranus. While I'll be talking about Uranus, I'll also be knitting some Uranus themed socks, and I think I got the colours pretty spot on here, which is amazing considering some of the other socks that we've made before. If you've watched some of my other videos, you already know the drill. We're just making the toe of the last sock. I've already got the other sock over here. And with that, let's get started with talking about Uranus. So we'll be talking about its beautiful blue colour, its gorgeous moons, its rings, and its downright stupid naming. So let's start off with what kind of planet Uranus, and by extension Neptune, is, and that is an ice giant. So similarly to Jupiter and Saturn, Uranus, and yes Neptune, is a giant, and it's got a relatively small core with a ginormous atmosphere. It should also have a mantle that's made of some sort of gas or liquid sort of material, so essentially a fluid, and also a mainly hydrogen and helium atmosphere. The main difference is that Uranus is an ice giant, and I don't exactly mean ice as in the water ice kind of sense, technically. Ices are essentially very volatile substances with very low freezing points, such as ammonia, methane, and of course water. In fact, the freezing point for methane is minus 182 degrees C, so it's pretty darn cold. The main difference is that the mantle should be made of a lot of these icy substances like ammonia, methane, and water, whereas when it comes to the gas giants, it's more so hydrogen and helium. Now, alongside temperature, pressure can actually also dictate whether a chemical is going to be solid, liquid, or gas. It's expected that Uranus's mantle is probably some sort of mix of liquid and gas, so like a fluid, but we haven't actually got any very good measurements of Uranus's mantle, so I can't say that with 100% confidence. Despite it being so far away from the Sun, it's expected that the pressure and temperature within Uranus, like in the mantle and the core, is actually extremely high, which is funny because the surroundings of Uranus is pretty much at near absolute zero. It's actually expected that because the pressure and temperature is so high, that the methane within Uranus might actually break up into its elemental parts, and you might actually, under the immense pressure, get diamonds forming from the carbon that's in the methane, forming essentially diamond hail, which is pretty cool. So now let's talk about the atmosphere, and most of our information on Uranus is actually on the atmosphere because it's the easiest to see. We can split Uranus's atmosphere into four main parts: the troposphere, the stratosphere, and the thermosphere and ionosphere together in order of increasing altitude. It's actually in the stratosphere and the thermosphere where you get a really big spike in temperature. This is because of the hydrocarbons and the methane in those actual layers interacting with the sun's rays and actually radiating a lot of heat, producing a lot of heat. The temperature there increases from a measly 50 degrees Kelvin up to a whopping 800 degrees Kelvin, which is ginormous. Now, I've just mentioned that methane interacts with the sun's rays, which is a really important point here because despite the fact that Uranus only has a couple percent methane by composition, this methane, because it reacts with the sun rays and it has blue absorption and emission lines, it actually is what makes the planet blue. This means the interaction with the sun's rays and methane is what produces the light blue colour around Uranus, and this also applies to Neptune as well, although Neptune is a lot more blue than Uranus and we're not too sure why. I think almost everyone knows this now, but Uranus has a really weird tilt of 97.7 degrees. This actually means that for the Uranian year, so 84 Earth years, it'll spend about 42 years in complete sunlight, one side of Uranus, and then also it will then spend 42 years in complete darkness. But because it's not a perfect 90 degrees, there is a small strip that actually just experiences really rapid day to night changes, which is really interesting. So why did this weird tilt happen? Well, we're not too sure to be exact, but one thing that we know is that it probably isn't naturally made. You see, when the planets form, they form from the protoplanetary disk that surrounds the baby star, and it's just more favourable for a planet to be spinning aligned with the disk's axis due to conservation of angular momentum and energy. So what we actually suspect is that there was a huge collision between some sort of Earth-sized or even bigger planet that would have knocked Uranus off of its feet essentially and tilted it almost 90 degrees or over 90 degrees. Now, tilted with the planet are Uranus's rings, but this is quite odd because the actual ring dynamics show that the rings themselves are much younger than the planet, so they might not have actually formed when that collision occurred. Now, I'm gonna forget this, I hope I don't forget this, but in order from the closest ring to the outer ring, we have 1986 U2R Zeta, that's one ring, 654, Alpha, Beta, oh dear, Eta, Gamma, Delta, Lambda, Epsilon, Nu, and Mu. And no, that's not how the Greek alphabet's order is. I know a lot of pictures from NASA and ESA and other space agencies make these rings look lovely and bright, but the truth is they're extremely difficult to see, and you probably wouldn't see them very well with an amateur telescope. The rings are made of very dimly lit dust and probably not too many ice, which actually has a very high reflectivity, which explains why they're so dimly lit. Intermingled with these rings are 27 moons, most of them having Shakespearean names. Titania is the largest of Uranus's moons, but compared to the rest of the solar system, it's only the 8th largest, which is quite surprising for an ice giant. The only reason I mentioned Titania is because of the absolutely stupid crater names, which all comes from Shakespeare and I think another bit of literature as well. I mean, they named craters Jessica and Gertrude. My favourite of Uranus's moons is actually the smallest one, Miranda. Mainly because it has so many beautiful features that all show evidence of previous tectonic activity, such as coroni, scarps, graben, and of course a lot of craters as well. I think it's just a truly mesmerising moon. The current name, Uranus, is basically named after Cronus, the Greek equivalent of Saturn. It took a whole 70 years after Caroline and William Herschel's discovery of the planet for it to actually have a proper name, with William the boy deciding to name this planet George's star. In 1782, Johann Bode proposed the name Uranus, and for reasons being that it actually fits in with the rest of the planet's names and it actually matches with Saturn's quite nicely. This name, also following the actual naming of the element uranium, thank goodness, caught on and the planet was finally given a proper name. Guess whose storage space ran out? Anyways, you didn't miss much. I was just looking around for a needle, couldn't find one. This is the only one I have left, so all I'm going to do, I've cut the yarn and just do exactly the same thing as before, finish off the end of the sock. So you haven't missed much, I promise. Okay, now let's just weave in those ends, finally. These have been on the needle for half a year. Oh, and I forgot that tail as well. Sorry about that. But anyway, I do give my sincerest apologies for the lack of videos. Unfortunately, being in the 3rd year of a physics degree is a lot harder than it seems. I've been quite busy with own research projects, people being annoying, and just loads of subjects, some chemistry as well, which we've been forced to do as well, so keep that in mind if you want to do a degree. Okay, that's one end done. I think I might just tuck in the other one before. I'll just tuck in the other one and just not finish it for now, because otherwise this video will be too long. But there we go. Our, is it 14th sock, I think? I've been very busy making socks, so there we go. We have, finally, our Uranus socks, and we've got the other one over here. Now, I'll just model them as well, just to show you how good I am at knitting. Okay, there is one. And we've got the second one over here. There we go. You can't even see that. There. Perfect. Some nice Uranus socks. And they do complement well the rest of the other socks that we've been knitting. Oh yes, speaking of which, I won't be doing an a Neptune video because I've already made one before, albeit not with the knitting, so I'll just make them in my spare time and show you them when I come to Pluto socks. Now, speaking about Pluto, I have two different colour choices that I could do. I could go with the more creative route and go with purple, since a lot of people, just a lot of things and art and media associate Pluto with purple. I mean, it kind of makes sense given that from all the other planets, purple isn't really used that much, and so it makes sense with Pluto. But we also have a slightly more accurate route with grey and red and white. I just can't decide which one I like. I mean, I kind of am going towards the purple, but I don't know, the other one seems pretty good too, so I'll let you guys decide. Anyways, with that being said, thank you very much for joining me. I hope to see you in the next video. It might be about Pluto, it might be about something else. It could be about AGN for all I know, because that's what I've been doing for almost 24/7 at this point. So I'll see you soon in the next video. 1986 U2R Zeta 654 Alpha Beta Eta Gamma Delta Lambda Epsilon Nu Mu. Okay, so 654 Alpha Beta Eta Gamma Delta Lambda Epsilon Nu and Mu. Okay.